Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And in this video lecture we will study one more numerical problem based upon the Lami's theorem, and the statement of the problem goes something like find greatest weight which can be spotted by two light strings making angles 60 degree and 45 degree with vertical, it being known that either string will break under the tension of W kilogram weight. So we have to find greatest weight which can be spotted by two light string. Now scenario is we have a weight say this is the weight and this weight is say W1 in the downward direction, and at this point this weight is supported by two light string. And first let me draw the vertical so that angle with vertical could be this is vertical and this point is point O, and this weight in the downward direction is supported by two light strings making angle 45. Let us say this is making an angle, this is 90, the in between is 45 degree. So this is making an angle 45 degree, okay, and another one is making 60 degree. So this will be 60 degree. This is making angle 60 degree. Fine. So this angle is 45 degree, this angle is 60 degree, fine, and this is point O where these forces are acting. Now since these are the light string means their weight is negligibly small. So and when these strings are supporting the weight W1, so there is tension because they are feeling the force in this direction, so the tension will be in opposite direction. So here will be tension, say this is T1 and this is T2. Tension is opposite to the applied force, and this weight W is acting is applying the force upon these strings in this direction, so the tension will be in opposite direction in this and in this. Since the strings are inclined at different angles, so the tensions will be different. So this is taken as T1 and this is taken as T2. Fine. Now we have to study and we have to find the greatest weight which can be supported by these two. Since these strings are supporting this weight W1, so we can say that the this system is in equilibrium because they are successfully able to support this weight W1. So we have no hesitation in saying that the system is in equilibrium. Fine. Now one thing you have to understand that, so we can also apply Lami's theorem. One thing you have to understand that as we go on increasing W1, as we go on increasing W1, these tensions will also increase because they have to support the more weight. So this tension will also increase, and we are given that if either of the string achieve the tension equal to W, the string will break, and once the string will break, this system will become void. So which string will break first, we have to see. By Lami's theorem, if we see, we have to find which tension is greater, T1 or T2. Among T1 and T2, which tension is greater, because we know that greater tension will achieve the breaking point, that is W kilogram weight, earlier than the second tension. So we'll see which one is greater, it is T1 or it is T2. Now by Lami's theorem, we know that the force T1 is directly proportional to sine of the angle between other two, this T2 and W1. What is the angle? Over a line angle is 180 and 60 is gone, so this angle is 120 degree. So this angle will be 120 degree. So this T1 is directly proportional to sine 120 degree. This implies that T1 is directly proportional to sine 120, sine 60 degree, and sine 60 degree is root 3 by 2, and it will be 0.866. Similarly, we find T2. T2 is also directly proportional to angle between T1 and T2. Over line 180 degree, 45 is gone, so we are left with 135 degree. So this angle is 135. So this is directly proportional to sine 135 degree. Okay, this implies that T2 is directly proportional to sine 135 is sine 45. Sine 45 is 1 by root 2, and this is equal to 0.707. Now among these, which one is greater, 0.866 or 0.707? Obviously 0.866 is greater than 0.707. So therefore it is clear that tension T1 is greater than T2. So whenever the breaking point will achieve, that will be achieved firstly by T1. So that W kilogram weight will come first in T1, not in T2. So now firstly using the Lami's theorem, then we will see that how we will exploit this result that we have just arrived at. Now using Lami's theorem, at point O, because the three coplanar forces T1, T2, W1 are in equilibrium, so we can use the Lami's theorem at point O. What does that state? Write these forces T1, T2 and W1. Fine. So what is T1? Sine of angle between other two, that is sine 120 degree. T2, sine of the angle between T1 and W1, this is sine 135 degree. W1, sine of the angle between T2 and T1, that will be 60 plus 45. This will be sine 60 plus 45. Now you will see when we will go on increasing W1, T1, because that will achieve, will also increase, and at one point this T1 will become equal to W kilogram weight, and after this if we increase W1 further, then this string will break, and when this string will break, this whole system will become void, become useless. So when we increase W1, this implies T1 also increases, and at one point it achieves its maximum, that is T1 is equal to W kilogram weight. Fine. Now taking first and third term, because we have to find W1, we have to determine W1, that is greatest weight which it can support. So taking first and third terms of equation number 1, we get T1 upon sine 120 degree is equal to W1 sine 60 degree plus 45 degree. T1 will become W. So I am going to substitute W by sine 120 degree is equal to W1 sine. I am not going to add up this because I am going to use the formula sine A plus B to find the value of this thing, sine 105 degree. This implies that we have to find W1. W1 is equal to sine 60 plus 45 degree into W by sine 120 degree, sine 60 degree, and sine 60 degree. I can write it over here, sine 60 degree. Now use the formula of sine A plus B. It will be sine 60 degree cos 45 degree plus cos 60 degree sine 45 degree. Fine. Into W by sine 60 degree, you know, is root 3 by 2. Now put all these values over here. We'll get W1 is equal to sine 60 degrees root 3 by 2, sine cos 45 is 1 by root 2 plus cos 60 degree is 1 by 2, sine 45 is 1 by root 2 into W by root 3 by 2. 2 to 2 will cancel out. Fine. So this root 2 will be out. So this is further equal to W by root 2 into root 3 is root 6, and it will be root 3 plus 1, which is W1, and units are kilogram weight. So this is the maximum weight it can support. If we will increase the weight beyond this limit, then the tension in the string, this string, and this can be named as, if you name it as A and name this as B, the tension in the string OA will increase beyond W, and this system, the string will break from here and the system will become useless, and the weight will fall under the gravity. So this system will no longer be in equilibrium. So the weight, if increased beyond this one, the tension in the string OA will increase beyond W and the system will break. So this is the W1 is the maximum weight this whole system can hold, that is these two string, light string T1 and T2 can hold. So we have to find the weight. This question is very important from examination point of view, and you must go through this question and understand the concepts that I have made you understand in this lecture. So that's all I have from this lecture, and very soon I will be with you with my next video lecture. Till then, take care, bye bye, and see you soon. This is Dr. Rajesh saying goodbye. Take care.